Hello friends, so we are adding one more day in the journey of CISSP. This video is the second video of domain 4 of CISSP. This domain covers communication and network security. In my last video I discussed about the concept of communication between systems. So systems identify any communication via the socket number, and socket number is a combination of three parameters: IP address, protocol and port. So in terms of CISSP exam, we must know some of the protocols and port number. So let's have a look on these. The first protocol is HTTP, which runs on port 80 and use the transport layer protocol TCP. HTTP is a hypertext transfer protocol, the protocol of the internet. Information is transferred in this protocol via plain text. Next protocol is HTTPS, which runs on TCP and uses port number 443. HTTPS protocol is using SSL previously, but nowadays it is using TLS over HTTP. This helps in securing the communication by encrypting the plain text into an encrypted form. The next protocol is SMTP, which uses 25, port number 25, and works on TCP. It is a secure message transfer protocol, the protocol which we use for sending email in plain text. We can implement TLS over SMTP, and in that case it will work on port number 587. Then we have POP3. POP3 is a post office protocol for email download. This is also a plain text protocol and it works on TCP 110 port. If we implement TLS on POP3, then it will work on port number 995. It means the default port number is 995. All these are default port numbers. Then we have IMAP. IMAP uses TCP port number 143. IMAP is Internet Message Access Protocol for active mail fetching. When we implement TLS with IMAP, then it will work on the default port number 993. After that, DHCP, BootP, both of these work on UDP port number 67 and 68. DHCP is Dynamic Host Configuration Protocol, which is we use for auto IP assignment, and BootP normally we use in secure booting an OS via network, like in PXE boot. Then we have SNMP, which is Simple Network Management Protocol. That is also a plain text protocol and it works on UDP port number 161. Next we have LDAP, which uses TCP 389. LDAP is a lightweight directory access protocol. So Microsoft AD, Active Directory, is an implementation of LDAP. Then we have SMB. SMB is server message blocks, which is used in file share and it works on TCP 445. Then we have NetBIOS, which works on UDP 137 and 139. So it is used for local name resolution in Windows and also for session setup. So whenever any two systems want to communicate with each other, then they will first create a session, and this NetBIOS will help in the same if those two systems are Windows system. Then we have Telnet, which works on port number TCP 23. It is also a plain text terminal access protocol, and Telnet application can also be used to check if the other system is having any other ports open. Then we have SSH, which runs on TCP 22. So it is a secure alternative to Telnet. Then we have FTP, which is TCP 21 and 22. So mainly the port 21 is used for control channel and port 20 for data channel. Then we have SFTP, which runs on TCP port number 22. It uses SSH for FTP to make it more secure. As FTP is a plain text protocol, so SFTP can be used to secure that particular communication further in an encrypted form. Then we have SCP, that is it also runs on TCP port number 22. It is a secure copy protocol. Then two more protocols are there which we need to understand. One is LPD and TFTP. LPD is a line printer daemon, so we can say it is a printing protocol. It runs on port number 515 TCP. Then we have TFTP. UDP 69 is the port on which TFTP normally runs, and it is a trivial FTP and it is used to transfer a small copy of files from one location to the other location, such as in Cisco router or Cisco switches or other routers and switches. We use a TFTP server to send the new images of the Cisco routers or Cisco switches or other network devices from the server to that particular device. Or we also use the same in VoIP communication. Moving further, friends, we need to understand the DNS security and the DNS way of communication when we are talking about the network security. So DNS is a hierarchical database with a tree-like structure. So I want to access a particular domain, then in that case I need to know that the URL which I am typing in the browser, that will be converted into a IP address, and this process of conversion from the URL to the IP address is taken care by the DNS. So the steps of the process which the system normally uses is, so when we type the URL, first the system check in the local DNS cache. If it is not able to find anything there in the local DNS cache, then it will check in the host file and LM host file in Windows, and then if it is not able to find the entry there, then only it will send a DNS query to the local DNS server. If the local DNS server is having the entry of that particular URL in its database, then it will revert back. If it is not there, then it will simply send our DNS request to the next level domain server, DNS server. Okay, so that's why we can say that we will have a root at the top, then TLD. TLD means top level domains. Below those, then we have domains, and then we have subdomains. TLD here means the .com, .in, right, .sg. All these are top level domains. So we can say DNS is making a hierarchical database with a tree-like structure. DNS normally uses port number 53, and this 53 is UDP. And whenever two DNS server communicates with each other, they transfer the information of the registered domains with them, and then that particular communication we call as zone transfer. So whenever there is any zone transfer, that uses port number 53 only, but on TCP. Okay. Some more terms are there which we need to understand in a DNS server. These are A record, AA record, then NS record, MX record, C name, PTR, zone file, and SOA. So A record maps name to IPv4 addresses, right? Like mapping of the URL to a particular IP address is A record. Then AA record maps the URL, it means the name of that particular website or portal, to IPv6 addresses. Then we have NS record. So it is a record of a name server that can respond to a record queries for a particular domain. Then we have MX record, which is a mail exchange record for email for any particular domain. Then we have C name, that is the alias name for a particular name. Then we have PTR. PTR is IP to name resolution. Then zone file, it contains all the A record for a particular zone or domain. Then SOA, so that is start of authority. It establishes the authorized name server for a domain. Okay, so these are the most important terms which we need to understand when we are talking about domain security. So DNS can be attacked by hijacking and spoofing a valid DNS address, which allow the attackers to redirect users to their deceptive portals. To implement security in the DNS, we can use DNSSEC, which is a Domain Name System Security Extension. So DNSSEC strengthens the authentication in any DNS using digital signature based on public key cryptography. With DNSSEC, it's not DNS queries and responses themselves that are cryptographically signed, but rather the DNS data itself is signed by the owner of the data. So whenever any particular owner want to add any DNS information like a record, then they will digitally sign it with their private key. And anyone who is taking that particular data from the DNS records, then they can verify the authenticity of the data by using the public key. Okay, so DNSSEC adds two important features to the DNS protocol. One is a data origin authentication, and second is data integrity protection. Data origin authentication allows the resolver to cryptographically verify that the data it received actually came from the zone where it believes the data originated. And data integrity protection allows the resolver to know that the data has not been modified in transit since it was originally signed by the zone owner with the zone privates. So we can say the DNS seeks to address this by adding digital signature to DNS entries, thus validating the authenticity of DNS lookups. At a minimum, signing the root zone is a necessary step in overall process, although DNSSEC must be deployed at each step in the lookup from the root zone to the final A record, that is the domain name. So DNSSEC only provide authenticity and it do not provide any kind of confidentiality. The other method of DNS communication protections or security are using a split DNS. It means using a external and internal DNS separate systems, providing more greater security. A simple DNS attack like a malware or any particular infection in the system can make modification in the host file of the system. So we can say that it will statically point a domain to a particular IP address which the attacker has selected. So we can prevent these kind of attack by enforcing privilege escalation control. Also, we can use some third-party DNS services which are free. Some of them are free also, some of them are paid also, which provide threat intelligence, which can also filter phishing and malware domains. One of the services is Quad9. It means the DNS IP address of the same is 9.9.9.9. So the next most important component of network security is a firewall. A firewall is a network security system that monitor and control incoming and outgoing network traffic based on predefined security rules, which we call as ACL, access control list. So firewall can be of different type like packet filter firewall, stateful inspection firewall, application layer firewall, or third generation firewall, or we also call them as proxy. And then we have next generation firewall. So the packet filter firewall used to control the network access by monitoring outgoing and incoming packets, and it also allow or block based on the source and destination IP address, protocol, or port. It means this particular firewall works on the concept of socket. Socket is a combination of three things only: IP address, protocol, and port. So in this type of firewall, the firewall will just check an ACL and the traffic. In the traffic, it will just check the message header. It means the packet header it will check. From the packet header, it will take this information, the source, destination, IP address, the protocol in the picture, and the ports of the source and destination. Depending on this, it will decide whether to allow or block the traffic. So we can say this particular firewall works on layer 3 of the OSI model. Next, we have the stateful inspection firewall. So this type of firewall, also known as dynamic packet filtering firewall. This firewall monitors the state of the active connection and uses this information to determine which network packet to allow through the firewall. So it verifies the state and allow access based on the IP port combination in the message header. This firewall works on layer 4. Then we have application layer firewall or third generation firewall or proxy. So these firewall can monitor and filter on the application layer, layer 7, and these firewall do traditional filtering such as packet filtering and stateful packet filter inspection also. So we can say application layer or proxies are able to look deep within the packet, the traffic of and content of the packet, and look for any inconsistencies, invalid or malicious command and executable programs also. Next is next generation firewall. These firewall do deep packet inspection and also do port or protocol inspection, and also they do some application level inspection, intrusion prevention, and use intelligence from outside the firewall. Two more important concepts in firewalls which we need to understand. These are tier and firewall sandwich. So tiers are secure zones of a firewall which are ideally separated by interfaces, forcing traffic to be scanned while traversing those zones or tiers. So we can say that tiers are internal zones. It means Wi-Fi, this WAN or internet is not counted as a tier in any particular firewall. Like while we are taking the very first example, in the first example, this particular firewall is connected via three interfaces. One interface is ISP, second is DMG, and the third interface is a LAN connection. So in this particular, we are not counting the ISP, and we call this particular firewall as a two-tier firewall. The second diagram is saying that it is a three-tier firewall. The reason for the same is, again, we are not counting the interface of the ISP. And there are three zones created here. One is a DMG, other one is a LAN, and the third one is a DB, database zone, or we can say a production like that. So the second concept is a firewall sandwich. When we use two firewall layers of firewall, ideally to secure internal and external layer of the enterprise, then the in-between layer of those firewall, we call it as a screen subnet, and the structure we form, we call it as a firewall sandwich. Okay. So this is also a three-tier firewall only. The third example is also of three-tier firewall because they are one DMG, one LAN, and one DB, one database, right? So this is a three-tier firewall with a firewall sandwich because we have used two firewalls here. That's why we will call it as a firewall sandwich. And the interface in between them, we call that particular interface as a screen subnet. So the next security component is a Western host. Western host also means screened host. A Western host is a special purpose computer on a network which we design specifically for a particular purpose, and it is configured in such a way that it can withstand attacks. And we can do the same by minimizing the threat landscape of the system. Minimizing the threat landscape means disabling and removing all the extra services. It means for that particular specific purpose, except that particular specific purpose, we will remove everything from that particular system. So we can say it is hardened, and normally we keep these kind of system outside of the firewall or within the DMG, demilitarized zone, because normally they require connection to the untrusted network, or untrusted network here means the internet. So the next security term is DMG. DMG means demilitarized zone. So in computer security, a DMG network functions as a subnetwork containing a organization exposed outward facing services like web server, proxy server, then antivirus server. It acts as the exposed point to an untrusted network. Here the untrusted network means the internet. So the goal of a DMG is to add an extra layer of security to an organization local area network. Before it, so it means between the it is between the internet and the local area network. So the reason between the internet and local area network, we call it as a DMG, demilitarized zone. So when implemented properly, a DMG can provide extra protection in detecting and mitigating security breaches before they can reach the LAN. So in DMG itself, there are some more concepts like the concept of well-homed host. So host with two interfaces like a firewall, we call them as a well-homed. So well-homed host is a term used to reference a type of a firewall that uses two or more network interfaces. One connection is an internal network and the second connection is to the internet. So in this, we also need to understand the concept of NAT and PAT. So NAT is network address translation and PAT is port address translation. So NAT is the process where a network device, usually a firewall or a proxy, assign public addresses to computer or a group of computers inside a private network. The main use of NAT is to limit the number of public IP addresses an organization or company must use for both economy and as well as for security purpose. So NAT can be of two types, static NAT and dynamic NAT. In static NAT, there is a one-to-one mapping, but in a dynamic NAT, there is a one-to-many mapping. But still, the number of public IP addresses remains very minimum. So that is the reason we use the concept of PAT. In PAT, even if we have a limited number of public IP addresses, then there is no limitation on the private addresses we can use. Right? So here in PAT, we use the concept of a socket number again, as server identify every unique communication by the socket number only. In socket number is combination of three things: the IP address, the protocol, and the port. So in PAT, the IP address will remain the same because all the internal servers, all the internal hosts are accessing a single public IP address, but they can use different port numbers. So using different port numbers, the socket number of each and every system, or even we can say the socket number of each and every communication from those system is different, and using that particular socket number, the server identifies those systems separately, and they will send the communication to the particular socket number only. So it is mainly, PAT is mainly used for outbound internet connection from the LAN. So the next in network security, we are having an IPS and IDS. So IDS is intrusion detection system and IPS is intrusion prevention system. So both of these play a very important role in network security. As we add any firewall in any network and limit the traffic to a particular port, IP address or services. But that limited traffic can also have malicious intention or malicious traffic, which can further exploit the vulnerabilities on the running services or port. So the answer to limit this particular malicious traffic is IPS and IDS. So these two will compare the network packet to a cyber threat database which have some known signatures of cyber attacks and flag any matching packets. So intrusion detection system just generate alert, but an IPS intrusion prevention system can also analyze packet and then stop that particular packet. So it can take a active decision. Okay. So we need to understand the different classification of these IPS and IDS. So they can further be categorized as signature based, anomaly based, and behavior based. Signature based means knowledge based. These IPS or IDS relies on a known signature preset pattern database to detect and prevent against attacks. So attackers are increasingly aware of this technique and they modify the attacks to evade this particular kind of protection. So that's why we can use the anomaly based. So these anomaly based IPS or IDS, they create a baseline of the whole network traffic, and then can they identify the anomalies in the traffic patterns and protocols. Also, we can use the behavior based IPS and IDS, which monitor for behavior using artificial intelligence for the attacks. So we call them as our expert systems also. But when we are talking about IPS and IDS, then normally whenever they find any match, okay, in the network, then what exactly they will do, they will generate an event. So whenever we found any particular event, we need to classify the same. We need to classify that particular event as false positive, false negative, and true positive. So we need to understand these terms also. So the false positive is when the IPS report on genuine traffic. It means the IPS has generated an alert, but when we checked, we found that the traffic is a genuine traffic. So we will classify that particular event as a false positive event. Then we have false negative, when the IPS do not report on malicious traffic, and this kind of condition is very dangerous for our network. It means whenever there is any malicious traffic and the IPS is not detect on the same, then we call it as a false negative. Then the next term is true positive. Whenever the IPS report on malicious traffic, it means the IPS has reported and the traffic is also a malicious traffic. So we call it as a true positive.